Hi students, how are you? I hope we all are fine. This is another session of sound lesson. In previous session we already discussed the vibrating body producing sounds. Sound has an energy and musical instruments are producing sounds. In this session we are discuss sound is a needs medium or not. Sound needs medium to propagate. Yes or no? Propagate. Yes, sounds needs medium to propagate. What are the mediums? Sound needs three medias. They are air, liquid and solid medium. Air sound needs air, liquid and solid media. In our school bell ranks in the ground floor, we are able to hear in the top floor. How it is possible? The vibrations are transferred through this air media and reaches our ears. That's why we are able to hear that ring. That's why air is one of the media. We all are know this best example in your childhood days. We all are play with this one. Take two match boxes, empty match boxes, tie with a thread, tightly tie with a thread, and you and your friend are talking to each other in a separate rooms. We are able to hear the voice. Why? Because air is the one of the media to transfer the sound vibrations. In air, the speed of velocity is 330 meters per seconds. In air, the vibrations are speed of vibration seconds. Velocity is 330 meters per second. Next, coming to the another media, liquid media, second one. In liquid media, when compared to the air media, in liquid media the sound produces, the vibrations produces loud sound. Take two buckets of water and we take two, see this experiment. Take two buckets of water, and fill with water. Take a bucket and fill with water. You take two stones. You rub it in opposite directions on the top of the bucket. We listen less sounds. The same experiment is repeated in liquids. We rub the stones in opposite directions in this liquid. We hear loud noise when compared to the air medium. That's why liquid is a strong intensity when compared to the air. The speed of velocity in liquid is 1490 meters per second. Next coming to the solid media. Solid media has more loudness when compared to the liquid and air. How you know? In a table, we are able to hear your voice both sides of the table. We hear clearly. We close the door and we are talking loudly. We'll reach it to the others. Solid has a high loudness. The speed of velocity in solids is 5000 meters per second. See, when compared to the air and liquid, solids are very high speed of velocity. These three medias are, through these three medias, the sound is propagated. That's why sound needs, what it needs? Media. Sound does not travel in vacuum. Sound does not travel in vacuum. Sound does not travel in vacuum. How we know that? We know. We will do a small experiment. It is a little bit tricky. See here. Take a glass. Keep a cell phone here. we make a sound to this cell phone. The sound intensity is, we are able to hear the intensity of the sound. We suck the air of this glass with our lips, tightly pack the glass to our lips. We suck all over the air. It is difficult to do this experiment. Suck the all air from this glass. You ring the cell phone. We are not able to hear the sound. The sound intensity decreases. Here, sound intensity decreases. Why? Because there is no media to transfer the sound. Now, eardrum. How eardrum react or sounds? We will see. This is our external ear. See how the ear sound mechanism going on our ear. See, this is the outer ear, this is middle ear, this is inner ear, this is eardrum, cochleae. Cochleae is filled with fluid. First outer ear caught the sounds. It transfer into this middle ear to inner ear. Inner ear have eardrum. When the sound reaches to this eardrum, it will vibrates. It produces vibrations. These vibrations passes through malleus, incus and stapes. These vibrations transfers through this cochleae. These cochleae have fluid. In this cochleae we have fluid. The sound vibrations passes through this fluid, reaches this cilia. Cochlea has cilia, hair-like structures. These cilia convert these vibrations into electric pulses. These electric pulses catched by nerve cells. The nerve cells give signal to the brain. Then we recognize the particular sound. This much mechanism is going on our ears. External ear caught the sounds and transfers into the middle ear and reaches the inner ear. It produces vibrations. These vibrations passes through this cochleae, and this cochleae is a fluid filled up with fluids. The cilia transfers this vibration into electric pulses. These electric pulses catch by the nerve cells. The nerve cells give the signal to the brain. Brain recognize the particular sound and send the reaction to that particular sound. This mechanism going on in our ears. The next one is sound characteristics. Sound characteristics.
The paper this
Sound has two characteristics mainly. One is loudness and another one is pitch. What is the loudness and what is pitch? Loudness is nothing but intensity of the sound. What is the loudness is nothing but what? Intensity of the sound. For example, we all know a simple pendulum. See here, this is the simple pendulum. We apply the force on this, it will be oscillate here to here. Again, it come back to the original position. This is the mean position. This is the extreme position. Extreme position. This is the mean position. The distance between the mean position and extreme position is nothing but what? Amplitude. Amplitude. If amplitude increases, the loudness of the sound increases. Loudness is nothing but what? Intensity. When compared to the man's have louder voice. See here, this is a table. Here we keep a hexascale to balance this one. Put a weight here. We apply force here on the hexascale. It will vibrate like this. Up to here and here it will be vibrate. This is the mean position. This is extreme position. This is the amplitude. The sine graph of this amplitude is this is the mean position and this is the extreme position. The distance is high means the amplitude is high. High amplitude is nothing but loudness is high. Here the distance between this mean and extreme is low. The amplitude is low. The amplitude is low. It will less loudness. The voice is less loudness. Loudness is nothing but what? Intensity of the sound. It is a intensity of the loudness is nothing but intensity of sound. It depends upon the amplitude. Amplitude increases, loudness increases. Loudness increases, amplitude increases. Amplitude increases, intensity increases. Intensity increases, loudness increases. Now coming to the pitch. What is the pitch? Frequency. Pitch is nothing but what? Frequency of the sound. High frequency. The frequency is very high. That is nothing but what? Pitch. When compared to this man, women have high pitch voice. Okay. Here also same this one. Frequency is nothing but what? Frequency is nothing but number of vibrations. Frequency is nothing but number of vibrations. Number of vibrations in 1 second. 1 second. How many vibrations we take in 1 second? How many vibrations take in 1 second is nothing but that is the frequency of the object. Frequency is measured in hertz. Frequency is measured. Units of frequency is hertz. For example, if the frequency of this particular object is 20 hertz and 35 hertz, what is the high frequency? In these two, 35 hertz is the high frequency. Frequency is nothing but what? The number of vibrations in 1 second. Women have soft voice and high pitch when compared to the man's. The bar graph is like this. High pitch means more waves. High pitch means more waves. This is the high pitch graph. Low pitch means less vibrations. Are you clear, students? These two are the sound characteristics, loudness and pitch. Loudness is nothing but amplitude, pitch is nothing but frequency. Are you clear? If you have any doubts in this, comment me in our comment section. Next, coming to the units of the sound. Sounds is measured in decibels, capital D and small b. Sound is measured in decibels. Our ear able to hear 60 decibels voice. The normal conservation between this, we are able to hear between 60 to 80 decibels. Above this one, above these limit, if our conservation is above this limit, our eardrum is damaged. We will go to sick, headaches, illnesses, sleeplessness, all. Most dangerous sound is car horn. Car horn has 110 decibels sound. Jets, flights have 120 decibels of sound. Car horn is more dangerous to our eardrum. 60 to 80 decibels is able to hear in our ear. This is about the units of the sound. How to sound pollution? How to reduce the sound pollution? Where we see the sound pollution most probably in traffic signals. So many vehicles are there and produces different types of noises, and also industries also, newly constructed buildings. These all produces more sound it creates sound pollutions. How to reduce the sound pollutions? We are able to invent less sound making machines in industries and constructions also. We are able to use less sound noise coming instruments, and also less horn vehicles, and you use sound sensors in the traffic signals. These are the some sound reducing ways. Thank you students. If you like my video, please give a big thumbs up, like my video, share my video and subscribe my channel. Hit the bell icon. Thank you.